we are going to solve a problem about application of torque in the gym. From the picture, we can see that there is a weightlifter and leg exercises. The weightlifter has several forces exerted on his lower leg. A simple diagram shown to the left. This The plate exerts a force of 113 newtons at an angle θ1 of 15 degrees. The quadricep muscles, I'm simplifying the biology here, exert a force at an angle θ2 of 20 degrees at a position 5 centimeters from the joint. This The force from the joint is an unknown angle, but we can ignore it since we will put the pivot point here, meaning the joint force creates zero torque. A typical lower leg has a mass of 4.35 kilograms and length of 40 centimeters. Calculate the magnitude of the force of the quadriceps on the lower leg. This problem is about the application of torque in the gym. We are going to analyze leg exercises using a weightlifter. In the first step, we have to identify what information is given from the equation and then write it down. Given the length of lower leg L equals 40 centimeters. Then we must convert to meter and we get 0.40 meters. The magnitude of the plate force F plate equals 130 newtons. F plate. The angle of the plate force θ1 equals 15 degrees. The distance of plate force from joint the plate equals L equals 0.40 meters from joint to the plate force. The angle of quadricep force θ2 equals 20 degrees. And the distance of the quadriceps force from the joint, the quadricep, equal 5 centimeter, and then we convert to meter, we get 0.05 meters. This the pivot to quadricep force. The mass of lower leg M equals 4.35 kilograms. The distance of the center of lower leg mass from the joint dw equals a half of length of lower leg. It's equal 0.20 meters. And the gravitational acceleration or G equals 9.8 meter per quadratic second. Then we have to identify what is being asked in the problem and write it down required. The magnitude of the force of the quadriceps on the lower leg F quadriceps is, then the solution is, for this case, using torque in the gym means rotating your legs into stable positions before and during movements. At the joint, we are ready to set up equilibrium for the lower leg, so the net torque at this joint is 0. The net torque equals 0. Based on this diagram, we can see that there are 3 forces acting on the lower leg. The first is quadricep force, the second is lower leg weight, and the third is flat force. Based on this, we can know the third direction for each force. The third by the quadricep force is counterclockwise. The third by the lower leg's weight is clockwise. And the third by the plate force is clockwise. So the net torque equation for this case is quadricep torque, plate torque, and weight torque equals 0. We know that torque is a cross product between the distance vector with the force vector. So we get the equation this, then we get this. Operate the equation to find the force of the quadricep on the lower leg, while we know that weight equals mass times gravitational equation. The gravitational acceleration. Thus, the equation becomes this. And after we operate, we get the equation for the force of the quadricep on the lower leg like this. Then substitute the variable values. The result is F quadricep approach 928 newtons. Thus, the magnitude of the quadricep on the lower leg is about 928 newtons. Thank you for watching. Don't forget to like, comment, share, and subscribe. See you in the next problem.